design a web crawler. Hi everyone, we're here today for another Exponent mock interview with Andreas. For those of you who aren't already familiar with Exponent, Exponent helps you get your dream tech career with our online courses, expert coaching, peer-to-peer mock interviewing platform, and interview question database. Check it out at tryexponent.com. All right, thanks for being here with us today, Andreas. For our viewers, would you quickly introduce yourself?
Hey everyone, it's great to be here today. My name is Andreas and I work as a software engineer at Modern Health, which is a startup located in the Bay Area.
Great, thanks for being here. So let's get started. Our question today is, design a web crawler.
Awesome. So thinking about this design, I guess I would want to start off with thinking about what sort of media should this crawler consume? Like, what are we thinking?
Just for now, let's just do HTML pages, but your web crawler should be extensible so that in the future it can handle other types of media.
Okay, amazing. And what types of protocols are we thinking we want to be able to crawl on the internet for?
Let's just stick to HTTP for now, but again, it should be extensible, so maybe in the future it can handle FTP or HTTPS, etc.
Great. And also I'll pull up my screen and I'll start writing down some of these requirements. So we know we want to have, all right, HTTP, we're going to handle HTTP protocol, and we also are handling just HTML files for now, but ideally in the future we'd be able to expand it to other types of files. And so, or other types of media. And in these cases, let's see, maybe we could start thinking about some of the features we'd like to support in the web crawler. So how does that sound to you?
Yeah, that sounds perfect.
Great. So some things we can think about are, here, I'll type it here. First off, we'll probably want something like, we'll want to be able to monitor our politeness or our crawl rate as we're navigating the web. In a lot of cases, we don't want to over use the resources of a given server or a service. And additionally, awesome.
That's smart.
And then on top of that, a DNS query. So DNS query will help us resolve the websites faster. We won't get bounced around to a bunch of IP addresses that they might have their service running on. We'll have distributed crawling. We want to make sure that we can do this efficiently and there's no single point of failure where something goes down in the system. We also want priority crawling. So how do we handle multiple, which sites to crawl? You know, how do we rank those? And then one more thing I can think of off the top of my head is probably duplicates. So not continuing to go over sites that we've already seen. Or in the case that we're on one given page, we don't cycle through one page over and over because it maybe self-references or something like that.
Yeah, that makes sense.
Awesome. So given this feature set, I'd love to start talking about maybe the scale of the system, of how we can expand it to, you know, how many users that we're going to need for this.
Okay, that sounds good to me.
Great. So starting off from here, so we're probably going to say that, let's say the internet has probably 900 million registered websites. And of those 900 million websites, we can probably estimate that 60% of them, or around 500 million, are actually like up and running. So given that, and And if they're up and running, they're also probably crawlable, or maybe they have other issues. So then, given each of those sites, so we have a total of 500 million sites. Each of those sites, we can say maybe on average has 100 pages. And they can probably vary from anywhere from 1 to 2 pages to, let's say, 1,000 pages, like on something really big like Facebook or other, even Facebook's probably even bigger than that, but 100 probably is sufficient. Would you agree?
Yes. Yeah, that sounds good.
Awesome. And so given that, we want to say, okay, we have 500 million sites, 100 pages per site. That gives us about a total of 50 billion pages to crawl. So given 50 billion pages, we're going to also need to be able to factor in the page size of each of these individual pages. So maybe we can estimate these pages to be about 120 kilobytes per page. And that's just at the top of my head guess, but we could give or take maybe 10, 20 additional kilobytes. And so this is probably because in this case, since we're just crawling for HTML, we'll also only need to pull in HTML, as well as in some cases we need to do JavaScript and CSS, especially on like single page applications where we'll need to render it before we can see the whole site. And so that will get us around, let's see, 50 billion times 120 kilobytes gives us around, what's the math there? I think it's like 6 petabytes worth of storage. So given that, we can save all this, and let's say it's like plus or minus 1 tolerance of that. So given all this information, we have to store it somewhere probably. But maybe before we think about that as well, like how can we optimize this? Because that's a lot of data. And maybe one optimization we can take a look at is just being able to take out the metadata to build like some sort of annotated index. So we don't need the complete page stored for every single page. And in the case that we do need to have the full page, well, we can compress all of these pages. And then if we do need to pull the full information of a page, then we can unzip it and just take a look at the contents. And maybe we can estimate after zipping and compressing all of that, we'll get down to half, which is about 3 petabytes of storage.
Okay, yeah, that's smart.
Awesome. So does all of that seem reasonable as far as scale?
Yeah, sounds good to me so far.
Great. So given that, I'd like to lay out some of the architectural goals that we want of this web crawler based off of this information. So given that, we're going to want, here, I'll put it right here. Given that, we're going to want to have probably scalability, since we're processing a lot of data and we're also going through millions of sites. In addition to that, we're going to want extensibility. So extensibility meaning maybe we have this, we talked about a duplicate detection and priority crawling, but there could be additional things that we'd want to check out for in the future, that we can't anticipate now, like malware or security. And we want to make that easily added in addition to these existing features we're wanting. And in addition to that, freshness of pages. So how do we continually renew these pages? And then server-side rendering. So like I talked about before with single page applications, we're going to need to render them on our side, on the server side, to be able to scan through them. Otherwise, we're not going to be able to read it because it'll just be a JavaScript bundle.
Right, yeah.
Cool. Besides that, maybe we can take a look at, like we said before, politeness will be an important part of how we architect this. And so that'll be relating to like how we respect the upper limit of the visiting frequencies that we have of these websites, because we don't want to consume too many resources on those servers.
Okay, yeah, that makes sense.
Awesome. And so do all these goals seem okay for us to proceed with the system design itself piece by piece?
Yeah, that sounds good to me.
Great. So probably the first thing that you need in any web crawler is a way to, here, actually I'll move over right here, is to have a way to seed the URLs. In this case, any system is going to need to, take into account URLs to be able to start the crawling process. And let's say we can take, in this case, since we're doing HTML sites, maybe our use case is like a search engine, something like Google or Bing. And in that case, then we want to say crawl the top 100 sites in every category on the internet. So like finance, entertainment, fashion, blogs, all of those sort of things. And then make a list of those and compile all that into seed URLs. And
Okay.
awesome. And so all of these URLs is basically one document that we can feed into our next piece, which is the URL frontier. The URL frontier in this case, essentially what it is it's a data structure that's built using queues. So it has priority and correctness built in. And if you want, I can go in, if you want to explore that further together, like we could go down that. But I think, up to you, yeah.
Oh, I'd just be curious to know, what are you prioritizing then in the URL frontier?
Yes, great. So in this case, like priority, it will be determined by what do we want to, in terms of URLs, to be able to prioritize, like which sites are we crawling. So in this case, I would imagine we would probably want to prioritize based on maybe traffic to the sites or, other rankings. Like I think Google has certain rankings based off of like how many people are referencing a given URL from other URLs. So that could be, let's say, a priority ranking we could do with those. Or if a URL is also really old, we need to refresh it. It hasn't been, and it's being hit a lot. That could be a way we could do that. How does that sound?
Yeah, that all sounds really sensible.
Awesome. And given that, okay, so we have this structure that allows us to prioritize the URLs to crawl next and returns that URL. Given that, we need to pass that URL to, here we go, call that URL. Pass that URL to this. And this is going to be a fetcher and renderer. So this is essentially a piece in the process that is going to handle the fetching and rendering, which I guess makes sense in the name. Pretty much what we need to do is that in this case, we can have several of these distributed in parallel, but each of these are implemented. We can implement it with threads or processes. Like Python has a way of implementing individual, like multi-threaded systems. And so we could implement that. Does that sound all right?
Yeah, so is the fetcher getting the content of the URL directly here?
Yeah, so we can say maybe in each of these components that it does two things. It's fetching, as yes, you're saying, we need to be able to get the content from the URL. So once this URL is passed from the URL frontier, then we're going to want to well, there's actually a couple things. We could just immediately call the page, download it. But again, as we talked about before, we would maybe end up getting routed through a bunch of DNSs or a bunch of IPs. So we probably need a DNS resolver to be able to fix that. So maybe as an intermediate step to speed up that process, we can add in a DNS resolver here. But just as you said, the fetcher is going to basically pull that page and whatever is existing on there and to be crawled. And if it's the case, it's just a standard HTML page, then work is probably done in terms of the fetcher. But if it's a single page application, which is more and more common these days, like a lot of people are using React and Angular and other SPAs, then we'll probably need to use some server-side rendering like Gatsby or Next.js, and we can handle that rendering on our side. Some people are also handling this on their side, but just to also be conscientious of not, relying on others to be able to do that, we need to make sure to do it on our end as well.
Okay, yeah, that makes sense.
Cool. And in this case, referring to politeness, as we're going through these individual pages, it'd probably be good to set the user agent to something like a crawling name like robot, where a lot of these sites will specify names where we can make sure to optimize or direct for crawler traffic.
Gotcha. So that's like a way of signaling to the website that your crawling traffic is coming from a bot rather than a human.
Exactly. Yeah, we don't want them to get angry with us and then block our traffic. So that'd probably be great.
Okay. Mm-hmm.
Cool. And then we have this DNS resolver fetcher renderer. Now that we have all this content, we need to store it somewhere. What do you like? I guess, do you have a preference of a storage system of like S3 or Bigtable or anything?
Not necessarily, but I do think you probably want some happy balance of both having persistent storage and also some short-term storage for that processes can access efficiently.
Yes, great point. I think we have these like large, thinking of long-term storage. I was just thinking of that, but I definitely think it would be important to, here, I'll add that here. Think about shorter term storage so we can be able to access that faster. So I'll call this long term, and we can just put a placeholder like Amazon S3 buckets. In addition to that, though, I think you're exactly right, and we definitely need some short-term storage. And so for that short-term storage, I think Redis will probably work, like some sort of cache. I think there's other types of cache, like Memcache, but I think Redis will be sufficient for this. So, okay, great. Now we can read and write. We're storing the data in these long-term data buckets to be able to access later. We have short-term storage in Redis to be able to quickly read, process the data. So how are we going to read and process the data? So given that, from here, from the fetcher, we can call another process here. And I imagine in this case we'll need some sort of queue for all of these responses since we're going through so many. If we tried to do it synchronously, I think it would just slow the system down a ton. So maybe we can queue up all of these sent from here. As soon as we store this, we can put this in in the response queue. So the two services I can immediately think of to handle that we talked about are going to be the main one, which is a URL extractor, and then the second one, which is the duplication service. Would you like me to talk about any additional services potentially?
This looks good to me for now.
And so given these, we have this URL extractor, which basically, actually, you know what, I'll start with a deduplication service because it's pretty simple. This deduplication service, I imagine we're going to want to, essentially when we have all these URLs that are in the short-term storage here. And given that, as we're going through these, we want to check if there's any duplicates in the short-term storage and then not extract those URLs. If we've already seen it, then we'll clear it from there. In terms of this URL extractor, that is probably the meat and potatoes of this, where we want to pull URLs from the page to allow the crawler to continue diving further into that same website or additionally leading to other websites. Most likely we'll use something like depth first search or breadth first search. I don't know if you have a preference. I think in this case, when in crawlers, I've enjoyed breadth first search to be able to exhaust a given page before moving on to the next one. But in those cases, also, it's really important that we normalize all of those URLs so that, because they'll have all sorts of additional like baggage tied to them, where it's like they might have, if it's HTTP versus HTTPS, and I know we clarified that before, which is great. So we'll just filter by HTTP. And in addition, things like if they're all from the same domain, then just characterizing them all under one domain and just having their relative paths.
Right. Okay. That makes sense.
So in addition to that, I guess we have, talking or moving back to our points here, we have extensibility as an important point. And right at this point is where we can allow extensibility. So from the response queue, we could add any additional services we wanted to right here to be able to, let's say, we talked about malware detection. That could be a thing where we don't probably want to download any viruses or anything off the internet that's going to mess up our system. Awesome. And so in addition to that, we can take these URLs that we've now extracted and we'll want to create, here we go. We'll want to create, I'll move this guy over here, clean this up a bit. We'll now want to start actually reprocessing those URLs because this is just a circle or never-ending cycle until we've crawled the whole internet, I guess is the plan. And so given this URL extractor, we specified, we talked about, we wanted just HTML pages. So this is probably an important point here to add in a URL filter. So given this URL filter, we've cleaned up and normalized all these URLs, and now we can give a second check here where if we already deduped them, which is great, but we'll probably need to check their MIME types. So in this case, to check that they're all HTML. In other cases, I could see, let's say we were building some sort of song searcher, then we'd maybe want to only filter by MP3s. But does that sound all right for you?
Yeah, that sounds great.
Awesome. And so now we've had all these filtered. We need to do one final check to be able to load all these URLs. So in this given pass, we've removed any duplicates, but what happens when we have also duplicates that we have already seen previously? Or how do we manage, if we have crawled a page before, maybe we do want to crawl a page again. How do we check on that freshness and then save the new version? And so I guess in this case, we'll want a URL loader. So what does this URL loader do? Essentially, it checks against if we've already crawled a URL. So we probably need to build some sort of search algorithm in this case, because it would be n time to search the whole database. And since we are, or whatever storage system we're using, and since we have such high scale here, it'll take way too long to be able to search through all of those to see if we already have it. So in this case, I would probably say we could use something called a Bloom data structure, Bloom filter data structure. And that case, it essentially, the drawback of it is I could see us ending up, it's not always correct, like it's not always right. It sacrifices correctness for speed. So in this case, we could miss some URLs, but I would, I guess, weigh that in this case, that's okay, because we'll probably pick up those URLs in another pass. Does that seem all right, I guess, as a trade-off in this case?
Yeah, that makes sense.
Okay, great. So given that, that's pretty much well, actually we need to store all of these. So we probably use something like NoSQL, or actually I would probably choose, in this case, a distributed file system to store all of these different URLs. And as I talked about before, I think we could use a strategy where we have the domain name at the top level of the file name, and then all of the relative URLs or URLs tied to that domain name. Does that seem like it would be, I guess, reasonable in this case?
Yes, yeah, sounds reasonable.
Awesome. So now we have all of these URLs saved and crawled, and if we've already crawled them, then we remove them in this case. However, if we add them here and then we don't want to now pass it to the beginning of the structure, which is, So we don't want to pass it to the beginning of the structure, which is over here at the URL frontier. But we will want to, I guess, in some cases, if we've already run across it, we will want to update it in here. If maybe we can add timestamps to those to be able to determine the freshness of how often we have updated that or when the last time was. And those timestamps then could be handled by the URL frontier about how they would get ranked or prioritized to being refreshed or recrawled.
Perfect. Okay. Yeah, so if you agree, I think this is a good place to pause.
Yeah, that's great.
Okay, yeah, so just a quick couple of follow-up questions. So you mentioned before that politeness was one of your design goals. So how do you ensure that your crawler is respecting each individual website's limitations on how much and where you can crawl?
Yeah, definitely. So I think in those cases, moving back over in this fetcher renderer, we talked about defining the user agent, but I think, yeah, we could be even more polite. using like checking if the website had a robots.txt file, then we could see the robot exclusion protocol. So basically we could define what parts, it would define what parts of the website we should not crawl, and also a delay time, which I think I mentioned before, but yeah, thank you for bringing up again, because the crawl rate is an important factor of being polite, and I didn't go into it here, but I definitely think that in that case, we want to respect whatever their crawl rate that they've defined for us in that protocol.
Yeah, okay, excellent. All right, so you did a fantastic job. Thanks for joining us, Andreas. I usually like to reserve some time at the end for us to do a little bit of debrief. So what were your thoughts on this interview? What do you think went well, and what do you think you'd want to work on more?
Yeah, definitely. I think this one is a pretty sizable one, so there's like a lot to go through. I would say I definitely would love to go into more of like this one maybe felt a bit hand wavy of the URL frontier, but I would love to dive deeper into that given more time, or and I really did enjoy doing the whole interview.
Great. Yeah, I enjoyed doing it with you as well. And I agree. I think you did a good job of trading off between covering the design at a high enough level that you were able to cover like all of the various different components that you needed but also enough detail that I understood what each of the components were doing, you know. I also really like that you explicitly listed out all of your requirements as well as your design goals. It made it very clear as like a preview of like what your design was going to be. And you did some really detailed back of the envelope calculations too, which were really helpful for understanding like what you needed for your design. Okay, one additional thing, I also really like that you mentioned the trade-off of, for the Bloom filter data structure, you mentioned a trade-off of exhausting, you don't necessarily need to exhaustively get all of the URLs, because efficiency is probably a little bit more important in this use case. Okay, some things that I probably would have liked to see a little bit more. I think it's always really important to talk more about like bottlenecks or like fault tolerance, for example. So you did mention, for example, that your crawler system is distributed, but I think I would have liked to understand a little bit more like how do you, like, if one of these crawlers that you distributed a certain set of URLs to crawl to like suddenly dies for whatever reason, then what happens? How do you make sure that like another crawler is able to pick up the slack, for example?
That's a great point.
Yeah, otherwise I thought this was great. Thank you so much, Andreas. And for those of you who are watching at home, good luck on your upcoming interviews.
Thanks so much for watching. Don't forget to hit the like and subscribe buttons below to let us know that this video was valuable for you. And of course, check out hundreds more videos just like this at tryexponent.com. Thanks for watching and good luck on your upcoming interview.